So before we begin, I'm going to pretend that this isn't up on the screen and you can't see your books. Let's just review all that you know about inverses. So look at me, not at the screen. Okay? What's one thing you learned about inverses yesterday?
Flip X and Y.
Good. You switch
Nice.
X and Y coordinates. Awesome. What else?
You gotta put that line through.
Mirror
Good.
line.
X equals
So the
Y,
original
yeah.
function or relation reflects in the graph of y equals x. Perfect. So that's the mirror line. One more thing.
So another-
Nice calculator.
Like when you,
Okay, yeah, that's actually a fourth thing. So we learned how to find the inverse on our calculator using the program.
oh yeah, flip X and Y and
Solving for
equation.
isolate Y
Isolate Y and all.
Okay, so algebraically we can replace again x and y. So we can solve that way. But there's one more thing. It's very important in math theory that we've talked about a lot.
It's a function or not?
Domain and range.
Oh.
What happens between an original function and the inverse function?
Oh,
What switches? Exactly. Basically, the domain from the original function becomes the range of the inverse function. The range from the original becomes the domain in the inverse. Okay, so the domain and the ranges essentially switch. Okay, that's basically what this first little bit has summarized, and you guys, for the most part, know your stuff. Okay, let's just take a look at example number 1. We're going to get into some graphs that aren't necessarily functions. Okay, so here we have the graph of x minus 3 all squared, okay, plus y squared equals 9. They're telling us it's a circle. The center is at 3, 0, and the radius is at 3. So describe how to use the graph of the relation to draw the graph of the inverse of a relation. So you guys mentioned it earlier, we would use the mirror line. Okay, so use the equation, or the mirror line, y equals x. So what we're going to do is we're just going to sketch the original graph, and just looking at a few hints, they tell us it's a circle. The center is at 3, 0. So let's start by plotting 3, 0. And they tell us that the radius is 3. So we're going to move over 3 spaces to the right from the center, 3 spaces to the left, 3 down, and 3 up. And that gives us enough information to connect the dots and draw a circle. And I'll try my best to draw a nice circle. It's alright. A little bit weak, but
Draw more of a square. Mine's just absolutely awful.
try again.
Art's not my thing.
So what you could also do is draw the mirror line in there, y equals x. And if we were to use a word to describe the transformation that we're using with the mirror line, what would we say it's doing? It's reflecting. Okay, so they did say use, but we could change that to reflect. Next unit, we're going to be looking all at transformations, so that's going to be important. Reflect in the mirror line. Okay, so just a review from yesterday to make sure you get some practice with your calculator. Sometimes it's a little bit tricky to draw the graph when you're just looking to reflect. So we'll just review with our calculator. So clear everything that's in your y equals. Make sure your graph is cleared as well. And let's take a look at this equation. Can I actually graph that yet?
No.
No. So we have to solve for y equals first. So if I started with x minus 3 all squared plus y squared equals 9, I'd want to rearrange to get y by itself. So we're isolating y. So I end up with y squared equals 9 minus x minus 3 all squared. And then we have to take the square root. So So we end up with, I'll just write it down below here, so y is equal to the square root of 9 minus x minus 3 all squared. Okay, let's just graph that, and I'm going to talk about some potential mistakes. I have left a piece of information out intentionally. And let's see if it constructs the graph that we're supposed to have, if it constructs that circle. So the square root of 9 minus, in brackets, x minus 3 squared, oops, minus 3 all squared, and then make sure you close the brackets if your calculator is like mine. Yes, sir? Okay.
My graph won't delete.
So I'm going to graph that,
That's super boring, will go away.
and what do you guys notice we're missing from our circle? The bottom half. What have I missed in my equation? When you take the square root of something, you need to take the
Plus or
positive
minus, yeah.
and the negative. Okay, just like if you think about 4, negative 2 times negative 2 is equal to 4. Positive 2 times positive 2 is equal to 4. So we have to remember that we have to take the positive and the negative case. If we put that into our y2, so the negative square root of 9 minus, in brackets, x minus 3, all squared. Close the brackets. Hopefully you'll see that you have the bottom half of the circle. Voila! So that was the first step, just graphing our function. But the whole point of this exercise is to find the inverse. So just by a show of hands, does everyone have a circle on their graph?
Nope.
Okay, I'll just come around and help out.
Got some weird triangles.
Let's see. Oh, that's probably from previous. Oh, I know. I forgot to minus.
Oh.
There you go.
Thank you.
Does anyone else need a hand?
See football.
I'm just going to put in a negative sign instead of the subtract sign. I think that's going to help. Yeah, so just be careful. If it's negative in front, you have to use the negative sign, not subtract. Okay, anyone else need a hand? Okay, good. So we have our circle, but the whole point is to find the inverse. So let's just quit out of our graph here. And you're going to go second program. This is from yesterday. Number 8. That's for draw inverse. And we now have to tell our calculator that we want to use y1 and y2. So we get that by pressing on bars. Go over to y bars, number 1 for function, and let's just select y1. Press enter again. And we've just basically taken the inverse of the top half of the circle. Okay, so it's reflected over here. We also need to take the inverse of the bottom half of the circle, or the negative half of the circle. So we'll quit out again, and we're going to go draw inverse, but this time we're going to use y2. So press bars, over to y bars, 1 for function, and this time we're going to select y2. So the graph that's in y2 is the negative square root of 9 minus x minus 3 all squared. And then enter again. Now, you can see a limitation to our graph. This circle should be connected, but it's showing a gap. There will be a connection there. It's just a limited graph. So technically, there is not a gap in your circle.
Silver edition can't get it out.
Okay, how are we doing? Did everyone get their inverse?
Where's this?
Thunder? Promise? Okay, good.
Definitely does not follow the y-axis.
Okay, so let's, before we draw our inverse graph, let's just talk about the domain and range of our original relation here. Okay, what is the domain of the original circle? Okay, remember we're calling it a relation, it's not a function. Okay, what is the furthest left and the furthest right the x values can go? What are the restrictions on the domain?
Greater than equal to 0.
So, yeah, good, is greater than or equal to 0 and
Less than or equal to 6.
less than or equal to positive 6. Good. Okay, and the range, the highest y coordinate will be 3. So it's less than or equal to 3. And the smallest y coordinate will be negative 3. So that's the domain and range from the original relation. We talked about this in the warm-up for just talking about inverses. What happens to that domain and range when we look at the inverse? Okay, it switches. So for part F, I'm just going to leave the screen like this, but for part F, okay, domain of the inverse function will come from the range of the original function. Oops. So the domain of the inverse function comes from the range. So it's going to be, x will be greater than or equal to negative 3. It will be less than or equal to positive 3. The range will come from the domain of the original function. Okay, so y will be between 0 and 6. By looking at the domain and range and then just switching them, it's a little bit easier to draw this circle now. So I know that my inverse graph will have to go for the y values between 0 and 6, and 0 and 6, oops, positive 6. Okay, and it's going to go between negative 3, 3, and positive 3. So within this box, I need to draw that circle. Okay, obviously it has to go in the center. So there will be my center. I'm just going to draw a few points and then I can connect the dots. Okay, and I've now drawn my inverse. You don't necessarily have to draw a box, but I find it helpful. Okay, so we've stated our domain and range of the inverse, we've drawn the inverse, but now we need to come up with the equation for the inverse. So when we're doing that, we have to switch the x and the y in the equation, and then solve for y. So just to give myself a little bit of room, the original equation was x minus 3 all squared plus y squared equals 9. We exchange the x and the y. So I get y minus 3 all squared plus x squared equals 9. Once we exchange the x and the y, we simply isolate the y again. So I'm going to leave the y minus 3 all squared on the left-hand side. I'm going to subtract the x squared to the right-hand side. Okay, to get rid of the square, I'm going to square root. So I'm left with y minus 3 on the left-hand side. When we take the square root, don't forget to take the positive and the negative square root of 9 minus x squared. Lastly, to isolate the y, we have to add the 3 over. So we get y equals positive 3 plus or minus the square root of 9 minus x squared. So if we were to put this in our y equals, we would need a y1 for the positive version and a y2 for the negative version. And if you put that into your y1, y2, you would get the exact same graph that we've shown here. Okay, so moving on. We've been talking about inverses, and we've been asked to find the inverse, but we're going to introduce a new notation for finding an inverse function. So first of all, it's important to note that if you have an f of x, or a g of x, an h of x, that is telling you you have a function. Okay, so if you have the notation f of x, it is a function. But if it's not a function, then you can't use that notation. Okay, similarly with the inverse, if the inverse is not a function, you can't use this new notation, the inverse of f of x. Okay, so if you see this here, that means the inverse of f of x. Okay, another form of writing the inverse of f of x is by saying x equals f of y. So our original function normally looks like y equals f of x. What do you notice that's happened with the x and the y? It's switched, okay? We're seeing the pattern with inverses. X and y always switch. Okay, that's it for there. Before we go to the steps, I also just want to point out another note that is important. Okay, and it's right here. Okay, so although 10 to the negative 1 is equal to 1 divided by 10, if we have the inverse of f of x, it does not equal 1 over f of x. So if you never thought to do that, or you didn't think of it at all, like, just forget about this. Just don't even think about it. Okay? The inverse of f of x does not equal 1 over f of x. So erase that from your mind if you ever had it in there. Okay, if you have to find the inverse of f of x, denoted by this, okay, these are the steps you're going to follow. So first, you're going to take the original function, f of x, replace it with y. Okay, then you exchange your x and y values, and you solve for y, and then you replace your y with the inverse of f of x. So let's look at the first example here. So we have a function f of x is equal to 2x minus 3. The first step we're going to do is rewrite f of x is equal to y. Okay, so f of x is equal to y, which actually equals 2x minus 3. Next step is you're going to switch the x and y. So we get x is equal to 2y minus 3. Then we solve for y. So first we're going to add the 3 over. We get x minus 3 is equal to 2y. Thank you. We're going to add it over. Just wrote the wrong thing. So add 3 over, and then we're going to divide by 2. Thanks, Chris. Last step is just to replace the y. With the inverse function. Because we've switched in the x and y, this is our inverse, so our final function will look like x plus 3 over 2 is equal to the inverse of f of x. Okay, so I'm going to leave this up here with the steps, and I want you guys to try B.